the graphical representation of acceleration. Okay, so the graphical acceleration basically is based on two rules. In this graph we can see on the horizontal axis we have time axis, and on vertical axis we have the velocity. Okay, so the slope of a velocity time graph, this is a velocity time graph. Okay, so the slope of a velocity time graph gives us the acceleration at that instant. Slope means velocity divided by time. Here in this case the slope will be velocity divided by time, because velocity is on vertical axis and time is on horizontal axis. So slope is always vertical axis divided by the horizontal axis. So the slope of the VT graph gives us acceleration. Okay, and second rule is the area enclosed between a velocity time graph. This is velocity, this is time, and this is velocity time graph. This is the area enclosed beneath this point and this point. So this is the area enclosed by the velocity time graph. Okay, this whole, this is the area enclosed by the velocity time graph. So the area enclosed between the velocity time graph and the time axis gives the displacement. Okay, so the slope gives us the acceleration. The slope of velocity time graph gives us acceleration, while the area under this slope gives us the displacement. Okay, displacement can be written as S is equal to, S shows displacement, S is equal to velocity multiplied by time t. Alright, so to summarize this slide, we have acceleration, which is the slope of velocity and time graph, and then we have displacement, which is the area under the velocity time graph. So slope is equal to delta v divided by delta t is equal to acceleration, while the area enclosed by this graph is equal to displacement, S is equal to vt. Moving on to our next slide. Okay, one more thing I'll tell you, that you can get all of these slides that I have prepared, and you can also get the lecture notes of these lectures of this course, of these chapters. You have to comment, and you will be provided with those lecture notes and with those slides, PowerPoint slides as well. I will also paste a link in my description to those lecture notes and slides. Okay, so now we have some different cases of velocity time graph. We have three cases. So looking at the first case, we can see that on a vertical axis we have velocity, on horizontal axis we have time. So as the time moves on, as the time passes by, the velocity stays the same. The velocity is not changing, so we can say this is a case of uniform velocity. So the acceleration will be zero, because in uniform velocity the final and initial velocities will be the same, so acceleration will be zero. Now in second case, this is time on horizontal axis, and this on vertical axis we have velocity. So as the time goes on, the velocity is increasing linearly in a straight line. See, this is a straight line, linearly increasing velocity. So increasing velocity in a straight line with a positive slope tells us that the object is basically accelerating. This is an example of uniform acceleration. Why? Because this is the final velocity, this is initial velocity, you can say v, and this is u. So v is greater than u. Final velocity is higher than initial velocity, so this is positive acceleration, uniform acceleration with a positive slope. The third example shows us that With time, the velocity is decreasing. The velocity is actually decreasing. This is our initial velocity u, and this is our final velocity here v. So v is smaller than u. The final velocity is lower than the initial velocity. So this has a negative slope. So it is uniform retardation, or we can say deceleration or negative acceleration. So horizontal line in this case, like here, horizontal line shows us constant velocity with zero acceleration. Straight line, positive slope, as in this case, straight line, positive slope. It shows us constant positive acceleration. And straight line, negative slope, as in this case. Straight line, negative slope. This shows us constant retardation or deceleration. So subscribe to my channel, like this video, and you can ask your questions in comment section as well. Thank you so much.